Okay, guys, got a quick request in. 64 and I think it's 91. So starting off with the 64 right here, it is a word problem that I will bring up in a moment. Okay, and it says as follows: an immersion heater with a resistance of 5 ohms. So I'm gonna take a quick note. Resistance equals 5 ohms. Uh, while drawing a current of 3 amps. Current is 3 amps. Um, what is the total electrical energy delivered to the water heater during 4 minutes? So T equals 4 minutes. And I'm just going to real quick do this, guys. Remember, we can't deal with minutes in this class. We've got to convert it to seconds. So this should be 240 seconds. Remember, each minute has, this is minutes, not meters. Each minute has 60 seconds. So this shouldn't be too bad. It's asking us once again, what is the total energy? So we're looking for energy, E. But remember, guys, E is also work. So I'm just going to go back a page, and I'm going to find my formula. I've got T, I've got R, I got I, and I see this formula. W equals I squared R T. And I'll just plug in. I'll go W equals 3 amps quantity squared times 5 ohms times T, which is 240 seconds. And you can just plug that in your calculator, and I think you should get the right answer. It's 945. 45 times 240 is 45 times 240 equals, I got this. Hopefully it's right. Equals 10800 joules. Is that a possible answer? Yes, it is. Yes, definitely a possible answer. Okay, so then let's go to the other question, 91. And sorry about the horrible picture drawing, but we've got this. We got a 60 voltage source, 60 volt potential difference source, A2, A1, this, and this. And this is clearly a parallel circuit you identify by its junction. So it's saying you got the circuit. Now, guys, if this is open right here, if this whole part is open, I'm going to neglect that resistor. That is outside the circuit. We can just ignore that because this switch is open, no current is going to go through this section. Okay, so we're basically just left with this. So you asked to find the current through the source. Now there's a couple of different ways you could do it. You could find you could go I1 plus I2 equals your I of your battery. That's an easy way of doing it. Now how do you get those? Well, uh, V1 equals I1 R1 and V2 equals I2 R2. And these are this is R2, we could say this is R1. Oh, that's the same thing, Mr. Shaw. There we go. That looks like a 2 uh, to someone, hopefully. And then, your voltage drop is the same for all these. So this would be 60, and you go 60 divided by 10, that gives you 6, and this gives you 3. So I think I'm going to go 6 and 3 is 6 and 3. Usually my mind's from like 9 amps. So that should be my current through this. Or what you could do is you could find your REQ. Because remember, I said one of the easiest ways to find the current through the battery is through REQ. So you could go V equals IB REQ. Now this is going to be 60 volts. IB. I just have to get my REQ. So I'll do it over here to the side real quick. Now remember, this is a parallel circuit. So it's 1 over 10 plus 1 over 20 equals common denominator times 2 times 2, 3 over 20 equals REQ equals 20 over 3 ohms. And then I could then go like this. That goes right here, 20 over 3 ohms. I'm going to scroll down just a little bit to give myself a little more space. Ignore this writing. And now what I'm going to do is I'm going to pick another color, and I'm going to multiply both sides by 3, which gives me 180 volts equals IB times 20 ohms. I just multiply by 3 on the bottom. And now I'm going to divide both sides by 20. And we get I equals 9 amps. Awesome. So both ways work. Once again, this one using Ohm's law, you can find the current here, and they add up to the current that goes through the battery. Or the other one using our REQs. Okay.